All right, welcome everyone. I'll give you a minute if you would like to follow the instructions on the slide to download OpenRefine and download the data set we'll be working with, and then we'll get started. All right, welcome everyone to today's online short seminar on data cleaning with OpenRefine. I'm Julie Goldman, Research Data Services Librarian at Countway Library. As a note, this session is being recorded and you will receive an email when the recording and the slides are available. So first, let me start off with some services and resources that may be available to you. The Publishing and Data Services team at Countway Library offers support for manuscript writing, copyright, research impact, data management, and bioinformatics. Additionally, the Longwood Medical Area Research Data Management Working Group has a website full of resources and information. This working group includes members of the entire LMA community, and this group has created this website as a portal for learning about data management and related topics. So I suggest you bookmark this website URL as it does have a lot of information to help you manage your data. And you can also find all the recordings from these trainings on the website as well. So let's review today's learning objectives. We will learn about OpenRefine and how to get started using it. We'll explore how OpenRefine can help with some common data cleaning challenges. We'll understand how OpenRefine can be used to standardize and clean data. And then I'll point to some additional resources for you. So to start, we should understand what data management is and why it is important. So research data management concerns the organization of data from its entry to the research cycle through the dissemination and archiving of valuable results. Data management aims to ensure reliable verification of these results and permits new and innovative research built on this existing information. And there are benefits to yourself, other researchers, and science in general by managing your data. So you will thank yourself if you document your systems so you don't have to rely on your memory. And data management facilitates these team transitions by allowing everyone on the research team to focus on the research instead of trying to decipher or find project information. Data management enables you to conduct your analyses effectively when collaborating with others. And anyone can check and verify your results when there are well-documented reagents, protocols, and data sets. And then the concept of data management helps ensure that data is findable, accessible, interoperable, and reusable. And of course, additionally, there is a movement among sponsors to require the data sets that underlie research funded by the public be made available. So we want to make sure we are being compliant with school and university policies, funding organizations that may require a data management or data sharing plan, and then also journals that require you to submit your data along with your article. So here's an example of the research cycle. And for this seminar, we are focusing on working with raw data and cleaning it for analysis. And a key step in preparing data begins when the data is originally entered and stored in tables, because this has an impact on the way we look at data later in our analysis. However, as we know, data is often very messy. So to prepare the data for that later analysis, it's important to have a clean data set. And as a note, if you recall our tidy data seminar, we explored tidying as the process of structuring your data in a way that makes it easy to analyze and use. In theory, you can only tidy a clean data set, but it can be argued that tidying data is just another step of this data cleaning process. So specifically, data cleaning is the process of detecting, diagnosing, and editing data. It includes merging and enhancing data sets, correcting for missing data points, standardizing and normalizing data entries, and verifying data. So ideally, to accomplish these steps, we should use a tool to save us time on the headaches that come with cleaning data. And it's important to know what you did to your data. So additionally, like that compliance piece, journals, granting agencies, and other institutions are requiring documentation of the steps that you took when working with your data. And with the tool we are going to talk about today, OpenRefine, has many powerful features. It is described as a powerful tool for working with messy data. But an overall motivation for using OpenRefine is you can capture all the actions applied to your raw data and share them with your publication as maybe supplemental material. Okay, so what exactly is OpenRefine? OpenRefine is an open source Java program that runs on your machine. It is a desktop application that uses your web browser as a graphical interface. No internet connection is needed, and none of the data or commands you enter in OpenRefine are sent to a remote server. OpenRefine can be used to standardize and clean data across your file, and it is more powerful than a regular spreadsheet program. So OpenRefine does not modify your original data set, which is good because you always want a nice clean copy of your raw data. And OpenRefine saves as you go, and you can return to the project at any time to pick up where you left off or export your data to a new file. And any operation that changes the data in OpenRefine can be easily reversed or undone. And as I've said, data cleaning steps often need repeating with multiple files. So OpenRefine is perfect for speeding up repetitive tasks by replaying previous actions on multiple data sets. Some concepts, such as clustering algorithms, are quite complex, but OpenRefine makes it easy to introduce them, use them, and show their power. So these are some use cases for OpenRefine, and they include cleaning data to discover and fix inconsistencies through faceting, clustering, cell transformations, and GREL expressions. OpenRefine is used for transforming data, so changing formats or reshape with functions such as split join, multi-valued cells, split columns, transpose columns and rows. OpenRefine can help extend your data set, so you can enrich your data by combining files, merging projects, fetching URLs, and reconciliation with online databases. And OpenRefine also helps with automating your process. So you can reuse your processing routine by exporting operation history in a JSON file and loading it on another file. And we will not talk about all of these use cases and actions today, but I will get you started and then point to additional places where you can learn about these more advanced functions. So if you would like to follow along, here are some instructions, and I'll put them in the chat once more. So you can download OpenRefine, download the data file to your computer. And when you load OpenRefine, it should load in your browser. But if it does not automatically load, there are some handy dandy links that you can use if you do not automatically load OpenRefine. I've also put those into the chat. So I hope you have already gotten set up so we can jump right in because we have quite a few things to cover. Okay, so once OpenRefine is launched in your browser, the left margin has options to create project, open a project, or import a project. And here we are going to create a new project with the data that we just downloaded. And we choose files and we find the spreadsheet that we just downloaded. I've put the link again on the slide. And then you click next. So I'm going to walk through that with you. So here we have OpenRefine loaded. We'll choose our files. Here's my portal rodents spreadsheet, as indicated right here. I click next, and I'll wait for my file to be uploaded. And I see a nice preview of the file, so we get a chance to make sure that OpenRefine understood the file. So for example, if your file was tab delimited, the preview might look strange, and you would choose the correct separator in the box shown and click Update Preview. But our data is comma separated, so we are all set there. You can also start over to find the correct file. And if all looks okay, we can create our project in the upper right. So I'm going to click Create Project. Looks like it's taking its time. Okay. All right, so we see that we have loaded our project into OpenRefine. We see what looks like our data set spreadsheet, and a few things to point out here. We are viewing the rows in our data set, and there are over 3,500 rows. And our current view is showing only 10 of these rows, but we could limit or expand the number of rows we want to see. And if you are having trouble downloading the data, you can always go back to that main page where you can open a new file and try uploading the data again. Okay, so for our first manipulation with our data, we will use faceting to look for potential errors in data entry in the scientific name column. So scroll over to the scientific name column, click the down arrow and choose Facet, Text Facet. So in the left panel, you'll now see a box containing every unique value in the scientific name column, along with a number representing how many times that value occurs in that column. So try sorting this facet by name and count. Do you notice any problems with our data? So right now we're sorting by name. We could also sort by count. So the problem with our data right now is there will be several near identical entries in scientific name. And these are due to misspellings that have happened to the data collection, at the data collection stage. So you can hover your mouse over one of the names in this facet list, and you should see that there may be, this edit function that we could edit these individually. So you could fix this error immediately. However, going through each of these would be very time consuming. So OpenRefine offers even better ways to find and fix these errors, which we'll use instead. And we will see how to correct these misspellings in mistyped entries when we talk about clustering. So first, to continue with faceting, facets are intended to group together common values. Using faceting, find out how many years are represented in the data set. So we can do that by faceting our year column, which is represented by a YR. So we come over to our YR column, and our years, do we think this column is formatted as a number, a date, or text? So to find out, we could try faceting. So generally you think of year as a number, so let's try faceting as a number. And when we do facet, numeric facet, just going to get rid of our scientific name, you see that there's no numeric value present when we try to facet by numeric. So by default, the column year is formatted as text. So we could facet by text, which would reveal, if we go year facet, text facet, we say that there are 26 unique entries in this column. But let's change the year to numeric inputs, since that is traditionally what year is represented as. So again, from our year column, we can edit cells, and a common transformation is to turn these cells into numbers. So we are editing our year column, edit the cells, common transformations to numbers. So now you see this is our numeric facet. It creates a box on the left panel that shows a nice histogram of the number of entries per year. Notice that the data is shown as a number, not a date. If you instead transform the column to a date, the program will assume all entries are on January 1st of the year. So that would not help us in this case. So we can now facet by text again, by count. So which years have the most and least observations? We created our text facet, and you can click sort in the box And the year with the most observations we see is 1997. And then the least is 1977. So we're quickly learning a little bit about our data very easily through these functions. So next, let's talk about clustering. In OpenRefine, clustering means finding groups of different values that might be alternative representations of the same thing. So for example, the two strings New York with capital N and capital Y, and then New York with lowercase n, lowercase y, are very likely to refer to the same concept. They just have capitalization differences. So clustering is a very powerful tool for cleaning data sets which contain misspelled or mistyped entries. So we're going to focus on our scientific name column again. And in this scientific name column, we're going to first recreate that text facet we created. And then we see this option cluster. We have a button called cluster. So we click this cluster button. And in the resulting pop-up, you can change the method and the keying function. So you can try different combinations to see what different mergers of values are suggested. So I'm going to keep the method key collision and then the keying function metaphone 3. And it should identify 3 clusters. Waiting for our data set to cluster. So we see 3 clusters, and you can see it's found some names, some of these species names that look very much the same. They just have slightly differences in some of their spellings. And you can pick which one you want to be the record of choice. And we usually choose, the name with the most rows to be the record of choice. So we can merge these under one name, checking the boxes merge. We can merge selected and recluster. So those will merge, and then it will see if there are any more clusters to do under the method and the keying function we chose. We don't see any more, so we're all set. So we can close our box. And then as you can see, the number of choices in our scientific name text facet has gone down to 21. Okay, so if data in a column needs to be split into multiple columns and the parts are separated by a common separator, such as a comma or a space, you can use that separator to divide up the pieces into their own column. So let's suppose we want to split the scientific name column into separate columns for genus and for species. So we can click the down arrow on our scientific name column, choose edit column, and split into several columns. And in our pop-up, we will replace this comma with a space. We will uncheck the remove this column button, and we will click OK. So we are separating what's in the scientific name column by spaces. And what you'll get is some new columns named scientific name 1, scientific name 2, and so on. Can't really see on my screen, but we've created multiple of these columns. So if you notice in our first entry, our first row, the scientific name 1 and scientific name 2 text boxes are empty. So why do you think this is? And what do you think we can do to maybe fix this? So the reason for this is the entries that have data in the scientific name 3 and scientific name 4, but not in the first 2 scientific name columns, had an extra space at the beginning of the entry. So leading white spaces are very difficult to notice when cleaning data manually. And this is another nice advantage of using OpenRefine to clean your data. So next we'll look at how to fix these leading and trailing white spaces. Sorry, I'm just checking the time to see where we are. Okay, so first we're going to rename one of our new columns. So if we click the scientific name 2 column, go down to edit column and rename this column. I'm going to type species because this is the species name into the text box, and I click OK. But then a pop-up tells me that there's already another column named species, and this is because there is another column that we've recorded the species abbreviation in. So you can choose another name like species name for this column, or change the other species column to species abbreviation. So I'm going to say OK. And we could come here and edit our species column. Rename this column. I'm going to add a species ab on the end. So now this is now species ab. And then I could go back to scientific 2 to edit our column, rename this column, and now I should be able to type in species with no problem. And yes, I get a little note saying I have renamed column species name 2 to species. All right, so we have been manipulating our data through a few steps. It's common while exploring and cleaning a data set to discover after you've made a change that you really should have done something else first. So OpenRefine provides undo and redo operations up here on the left next to our facet filter. So we're going to explore this. So we click the undo redo, and all the changes we've made so far are listed here. So we want to click the step to go back to. I'm going to go back to our step number 3, split, where we split our cells. And we should notice that we're going to go back to step number 2. If we notice, it is getting rid of the step where we split our columns. So the added columns have disappeared. We have our one scientific name column. So it's clustered, but not split yet. All right, so let's, in the last few minutes I'm going to take is to go back to our spacing issue. So words with spaces at the beginning or end are particularly hard for us humans to tell from strings. But the blank characters will make a difference to the computer. And we usually want to remove these. And OpenRefine provides a nice tool to remove blank characters from the beginning and end of entries that have them. So in our scientific name column, we hit the down arrow, we go to edit cells. Another common transformation we see is to trim leading and trailing white spaces. So we click that, let OpenRefine do its magic. And it doesn't seem like anything has changed. So let's try editing our cells again. We're going to split our column into several columns with that one space, keeping our original column intact. We click OK. And we see this time that removing the leading white spaces means that each entry in this column has exactly one space between the genus and the species names. So therefore, this time we see that we only get 2 columns for our species names, and that first row that hadn't had species name 1 and scientific name 1 and scientific name 2 rows filled, they're now nicely split up and filled. So the last thing I'm going to show is how to export a nice project. So by default, OpenRefine is saving your project as you go. If you close OpenRefine and open it again, you will see a list of your projects that you can go back to. You can click on any of them that you want to open. And in OpenRefine, you can export just your clean data or the entire project. And the nice thing about exporting your entire project, this means you're saving data and all the information about the cleaning and the data transformation steps that you've made. And again, this is helpful, for instance, if you wanted to send your raw data and the cleaning steps to a collaborator, or share this information as a supplement to a publication. So we can do that by clicking the export button in the top right, click our export project. And this might take a while, so I'll pop back to our slides. So we've exported our project. And then once that file downloads, it's a tar.gz file. It's a compressed file, but it contains multiple other files. And we see that we have a couple different files in here. And it contains, a change.txt file. And these changes, are the records of each individual transformation that we did to our data. So that would be found. So if we wanted to, go back into OpenRefine, we could upload this tar.gz file, and what would appear is the raw, the spreadsheet data, as well as all of those the history of those transformations that you could review. So that was a very, introductory overview of OpenRefine. And OpenRefine is more than a simple data cleaning tool. People are using it for all kinds of activities. Once your data has been cleaned, you can take the next step and explore other exciting features. OpenRefine, there are more advanced uses of OpenRefine, such as bringing in column or cell data using web locators or APIs. And here are some examples of how people are using OpenRefine. Just for reference, OpenRefine is more powerful than some other tools you may use for cleaning data. So you should use OpenRefine when you need something more powerful than a spreadsheet, more interactive than scripting, and more experimental than a database. So just to review what we talked about today, if you remember one thing from today's lesson, it should be that data is messy, but you can use OpenRefine for working with that messy data. OpenRefine is nice because it gives you a quick overview of how many empty values your data set contains, and how often a particular value is included in a data set. OpenRefine can help you split up data into more granular parts and solve recurrent issues such as duplicates and spelling inconsistencies. And don't hesitate to experiment with OpenRefine and the features as you're performing these steps on a copy of your raw data. And OpenRefine allows you to always trace back to previous steps in case you have made an error. So it's really nice functionality in that way. As I mentioned, here are some additional training resources for you. We went through the very beginning of a data carpentry lesson. There's also a library carpentry lesson that I would suggest going through if you're just getting started with OpenRefine. So please see this website for more on the topics we discussed today. I'm excited to say that we will be continuing seminars this summer. So I have a full lineup across July and August that you can now register for. So thank you very much for joining the webinar today. The recording and the slides will be posted on our website at the link on the slide. And I would appreciate your feedback on how today's session went. And of course, please let me know if there are any additional topics you would like me to present in the future. So please fill out the survey at the link on the slide.